provoker?
Yes, you had a thought, oh, yeah, that's right, you had a thought provoker number 2. Remember that earlier?
I
Then I already forgot about it.
Oh, me and Hayden did number 1. We thought it was number 2.
Oh, well, we'll talk about it, we'll talk about both of them then. That's why I said thought provoker number 2.
I just wrote thought provoker, so I didn't know which one it was.
That's why you want to be careful. Okay, I'll take that. Going into something a little bit different. Thought provoker number 2.
Where is it?
We'll talk about it. Where's your thought provoker?
Okay, number 1.
Okay. So, if you show me the proper thought provoker on Monday, it won't count as a homework offense because you did work. You just did the wrong one. This is what you were asking about a couple of days ago. So you did work. So I'm not penalizing you for doing work. You just did the wrong one. So if you show me the correct thought provoker today or Monday, it won't count as a homework offense. So make sure
If we do it in study hall and show it to you at the end of the day.
yeah, that works. It's just to make sure, it should give you Monday just in case you ran out of time. Okay, so same idea for you? Okay. So again, show it to me in study hall or show it to me on Monday.
Yeah, I accidentally. It was on the front, right?
Yep, just the front. I'll tell you just the front and back.
There's a back to this one?
Good job. Yep. And then, yep, move here so I can see it. Yeah, that's because you want to be very specific on why I said thought provoker 2 over and over and over again. Yes.
Whenever we're playing the treasure game and we have to like raise our hand, I'm gonna be using my left hand, so I'm gonna be really slow today.
Okay.
Because this arm is so sore. It hurt. I went to raise my hand to ask you the question, and I was like, nope. And just use my left hand.
Alright, let's go over, let's do the thought provoker first. Let's see, actually let's go over 1 because that is a good one. Now I know most of you didn't do it, but since 2 of you did it, let's go ahead and talk through that. And the one sitting here, y'all can also just think about it. So in science investigation, determined an experiment on page 26, the hypothesis was that water entered the bean seed only through either the scar or the tiny spot next to it. What prediction inferred from this hypothesis was used to design the experiment then in the investigation? Was another prediction you could use to test the hypothesis? Alright, Hayden, what'd you get?
I was really kind of confused, so
Okay.
Miss Morrison told me to like it wanted me to like write my hypothesis or something like that.
Yeah, that was for like the second part. So, what was your prediction? Because remember we were talking about making a prediction with the idea of deductive reasoning that, okay, if you think that the little scar is what's allowing water into the bean and you cover it up, what should happen to your bean seed then?
It should swell.
If you cover up the hole?
It should not swell.
It should not swell, so your bean should stay the same size. That would be your prediction. That's the first part for it. The second part, it's asking you, what is, let's see, what is another prediction that you could use to test the hypothesis? This one is the idea that you can come up with other predictions based off it, but the main one was that water won't enter the bean if you think that the water's coming through that spot. If you cover it, water shouldn't be able to get it on the inside. Alright, let's go through the second one now. Describe at least 3 models that can be used to represent your hometown. Your book gives you a bunch of different types of models for it. So let's go through these. Alright, Scott, what you got? Alright, that's one. Alright. And then what? Video. Is that what you wrote in your homework? I'm about to say, I'm pretty sure I saw something different. That's probably the reason why I wanted to talk to you about it to help you fix it, come up with the correct solution for it. But yeah, that was a good job fixing it. There are 3 different types of models that works for that. So you went through visually, you went through building a model, and what was the last one? Video. So you could do like a video for it, or like how your book points out, a computer simulation. You might have it to where if someone were to like try to like go down into your village, how they would walk around. Alright, you have anything else?
I said a verbal model.
Verbal models. What's a verbal model?
Reviewing.
basically you're describing it. Like if you were to read in a book and it's describing a town or describing a person, that's the idea of a verbal model. They're using words to talk about somebody. This is one reason why, like creative writing, Mrs. Henderson might have you practice writing like descriptions of people. That's part of the reason why is you're practicing with your verbal models, using your words to describe something. Okay. Okay.
A photograph is a model of a person, place, something.
Yeah, so if you take a picture, it is basically representation of it. So it's a type of model. You can see, oh, here's what it looks like. Alright, you can go ahead and put that away for right now then. Let's go over your activity key, the first part. We're probably going to do the second part in class together because I want to save you a little bit of time on your homework. You have a lot of homework. I want to try to save you a little bit of time. Yep, but it's the weekend, so we'll try it. It'll be a little bit easier. Alright, so let's look at that first one. So we'll do all the across first, and then we'll do all of the down ones. So, number one across, the term for anything that provides a partial representation of something else.
Model.
A model. Number 5, the classification that follows kingdom. Evie. That's it. Reasoning from specific evidence to a more general conclusion. Danielle.
Inductive reasoning.
That's inductive reasoning. Number 10, a sensible explanation about the objects and events in nature. Lana. Hypothesis. Plant life. Flynn. Flora. The place where an organism lives. Evie. Habitat. An inactive state that helps the organism to conserve energy. Scott. Dormant. The study of living things. Jaden.
Biology.
The father of taxonomy. Lana.
Careless.
Good job. Yeah. Carlos Linnaeus is how we say his name. But yeah, it is a mouthful. And then the area between the highest and lowest points that the tide reaches. Alright, Evie again. Good job. And the smallest unit of a living thing. Hayden. Cell. Alright, now let's go down now. Alright, the study of reasoning. Glenn. Logic. Conditions that are observed to determine the results of an experiment. Danielle.
Dependent reasoning.
Okay, you have dependent, right? What do you call that?
Variable.
There you go,
I read
variable.
the wrong word.
It's okay. The conditions that are observed to determine, oh, I just read that one. A hot spring and the ocean floor. Lana.
I know what it is, but hydrothermal vent.
Yep, hydrothermal vent. Classification, that is the first part of an organism's scientific name. Jaden.
The genus.
That's it. Introduce the scientific method. I was going to call on Hayden, but I need to, he can swallow really quick. Alright, Hayden.
Sir Francis Bacon.
Good job. So the small toe on the hind leg that does not normally touch the ground. It's talking about deer. I got a little bit confused for a second whenever I first saw that. Alright, David.
The dew claw.
Good job. No, I lost my spot. Number 12. Unable to be cut into equal halves. Scott. That's it. 17. A conclusion based on reasoning from evidence. Flynn. Inference. The classification level between between class and family. Jaden. Order. Alright, anyone have any questions about that? Let's go ahead and let's flip over and let's do the back. Yes.
I think we skipped number 15.
Did I skip 15? Oh, they did! A way of explaining an object or an event using a set of facts. Do you want then? Oh, okay. Alright, Hayden.
Theory.
Good job. Alright, back page. No, you didn't have this for homework? Well, let's go ahead and let's practice it because you have a lot of homework tonight. So let's go ahead and let's talk through this and think through this. Alright, James wants to know if his indoor plants grow better in the sunlight or in the shade. After observing how his plants grow normally, he states that he thinks that they will grow better in the sunlight. What has James just stated? Hypothesis, theory, experiment, or an observation? Alright, Glenn. That is correct. This is a hypothesis. Number 2, a scientist is studying how the climate affects the lives of lemurs, a type of monkey that lives in the island of Madagascar. What branch of biology does the scientist specialize in? Alright. Excuse me. Alright, Lana.
Zoology.
That's a very good guess. But see how it said it's saying how the climate affects the lives of lemurs. So if it's studying the environment with the lemurs, it's not just zoology. What is it then? Ecology. I know zoology seems very close, but ecology, because he's studying how the climate affects it. Number 3. The blue whale is known for being the largest animal on Earth and can reach up to 33 meters or 110 feet in length. The blue whale's scientific name is, ooh, Latin's been a while for me. So, Balaenoptera nucleus. What is its species name? Alright, good job. After reading the statement, a flamingo is a bird. All birds have wings. Ava determined that a flamingo must have wings. What type of reasoning did Ava just do? Alright, Glenn. Good job. Because that's the idea of, okay, if this first thing happens, then the second thing must also happen. So that's a type of deductive reasoning. Alright, Ethan is raising crickets and wants them to grow as large as possible. He decides to use a scientific method to solve the problem. What is his next step that he should perform? Danielle. Not quite yet, because remember it said Ethan is raising crickets and wants them to grow as large as possible. So you just decided, I want them to grow as large as possible.
Gather information.
Gather information is correct. So gather information, and then you're right. Then he can make his hypothesis, and then he can start to do his experiment and analyze his results. So you gotta gather information first. All right, do you have any questions about that? Back page. All right, you can go ahead and take out a piece of paper so we can write down stuff you don't know. Hopefully writing it out will help you to cement it in your head as fast as possible as we're going over this stuff. Yes.
Don't change the side or anything, and I have a question about this.
All right, back.
So on this, why is it like next to the number keys like these little white stuff?
It's to tell you whenever I click on it, it fades away.
Yes.
Okay, that's because someone had to go through and program the PowerPoint for it to like fade away instead of it going like immediately like to the next slide how a normal PowerPoint does. I had to get this from someone. They basically wrote in the PowerPoint code how the PowerPoint works and how to make it work properly. Because normally whenever you click on a PowerPoint, it jumps to the next slide. So I had to go in and tell each individual square how each individual one is supposed to go away from and come out of the camera so that we can't see you anymore. So that way it tells the individual how to do it. So if you like coding, this might be something you want to practice with. Now it's not the same as computer coding, but it's the right idea. You have to tell the computer or the machine basically step by step by step what to do. And if someone messes up, then it won't work properly. So that's the reason why they have this little sign section. It's telling the computer specifically, hey, this is what you're supposed to do over and over and over again. So instead of clicking and jumping to a whole new slide, it just makes a little bit square disappear.
I think the projector thing is too big. It's like not fitting on this.
Yeah, it's like because my computer is dying. It decided this week it no longer wants to live with us. So I'm going to have to either take it to a shop and get it fixed, or if that's too expensive, I gotta get a new one. So I'm using a substitute right now, and the substitute settings are a little bit different. So good observations. But yeah, it's gonna be like that for a couple of days until either I get a new computer or until I get a new one. Those are separate for a while. Alright, so thinking back over it, what is the study of reasoning? Cheaters.
Hayden?
Go. That was Danielle.
Logic?
Logic.
Number 10. I like the number 10.
You like the number 10?
I just love it.
It's a good number to watch.
I like the noise. I like the noise. Cause I like the noise it makes whenever you get the treasure.
Oops.
And at the beginning.
I should help fix it a little bit. Alright, what is a conclusion based on reasoning from evidence? Go. Okay, that was Scott. Inference. 28. Alright, what is, going backwards a little bit, what is the factor that you change to test your hypothesis? What's that one difference? Go. Okay. I think it was Jaden, but it was close.
Independent variable?
Independent variable.
32.
Alright, what is the group in which the independent variable is absent? So this one doesn't have the thing that you're testing. It's the one that's used for a comparison. What do you call that group? Go. Alright, that was Edie.
Control group?
That's the control group. Alright, pick your number.
16. Can you just click on it using your finger on the screen?
Because of how it's working right now, no, so I have to use my mouse, but typically you're right that I would be able to. Alright, what are the variables that are all the same in all your experiments, in all of your experimental groups? Go. It's gotta be faster line. Right, Scott. Independent variable?
Control variable.
Control variables.
24.
24. Alright, what is the variable that you're looking at to determine if your experiment, well, that's to see what's changing in your experiment, we'll put it that way. Go. I think you barely got it on it, really close. That's dependent variable. Alright. What is, let's see. Oh, how many independent variables should a good experiment have? Go. You was Jaden, but it was getting closer to the back row people.
3. I said 3, but.
Nope.
What?
One. Only one independent variable.
Oh, independent. I thought you said dependent.
Nope, one independent variable. What was that? 33. Alright, let's see. Alright, who introduced the scientific method? Go. Who? Okay, that was easy. Sir Francis Bacon. What is, alright, there are 3 main parts to the scientific method. What is, you know, you should probably be able to name all 3 by this point. Go. I think that was Scott. Good job. Alright, what do you call a sensible explanation to your, oh, I'm sorry. 34. Alright, what do you call a sensible explanation to your experiment or to your problem? Go. That doesn't help you, Hayden. Alright. Okay. Hypothesis.
Lucky number 7.
Lucky number 7.
And
Let's see. What is a way of explaining an object or event using a set of facts? So once your hypothesis has been proven by your experiment, and then people start to think you're right, what do we call it at that point? Go. That's a theory. What do you choose your number? Sorry. Say it one more time. 15. Alright. What do we call it if your theory has never been proven false? As far as we know, it's 100% true all the time. What do we call it then? Go. Cheater.
I'm not going to put that down.
Alright, Lana got it.
Law.
That's a law.
22.
22. Alright.
Oh man.
What is, let's see, facts about nature? Go. Okay, that was good. What? Data. I thought you said theory for a second. Alright. Just gonna give me for a second.
Let's go try.
Who's taller than me?
Scott.
Almost probably everybody. Alright.
Scott.
Come pose up really quick for me.
Scott's the tallest. Oh my goodness.
Oh my
Oh my goodness, Scott.
Thank you.
Scott's
Let's do the other one in a second. Alright. What is, going back then. Alright. What is the 2 parts to the scientific name of an organism? Remember, there are 2 parts to the scientific name. Go. Alright. That was Hayden.
Genus
Good job.
and species.
Good job. Which one's capitalized?
Genus.
And then which one's italicized?
Both.
Both. Good job. Choose your number.
23.
Is that 23?
Yes,
Alright. Alright. We'll do them all. We'll do this one all at once. Because y'all should know all of these by that point. If you're going from most broad to most specific, what are the 7 levels of the Linnaeus classification system? If you're going from most broad to most specific. Go. Here was Lana. Alright, Lana.
Kingdom, phylum, class, order, family, genus, species.
Alright, not too loud. Choose your spot.
14.
14. the father of taxonomy? Go. Alright, Scott. Good job. Choose 19. Alright, now move a little bit faster. Alright, what is the science of classification? Go.
Taxonomy?
Taxonomy.
What is it?
26. Alright, what is, let's see, alright, name his first original 2 kingdoms. You should be able to know both these kingdoms by this point. Go. I think it was Daniel.
Lente and
Anima or Animalia? Alright.
Yeah, she did get that one. I keep getting that one question. 29.
29. Alright, what is a distinct type of organism? Go. That was Jaden.
Species.
27.
27.
Yes! I got it! Alright, Scott, cover up my last couple of cards really quick for me. Go check this one out.
That noise.
Alright, think you guys go over it. Try not to cheat while Scott is putting these. It's okay, as long as they can't see it. While Scott is putting up these last couple ones for me. What is the first step to the scientific method? Alright.
Like the first general one?
No, the first, we're going through the 6 specific steps.
State the problem or ask a question.
Good job. What's the next one?
Sounds like.
Okay, whenever. What? Research. Gather information. What's the next one? Good job. What's the next one, Edie? Not quite.
Conducted an experiment.
Conduct an experiment. Then what? Analyze data, and then what's the last one?
Report results. I can see
You can see it through it.
You can see it? Come on, Scott, show another one for me one more time.
Yeah, you can. Glenn can't. I can clearly see reports.
Alright.
Glenn, you just said that.
I cannot see through it. How can you not see through it?
Because we can. Scott.
Alright. Go ahead, take out these papers that way. You can use it as a cover sheet to are fairly close together.
Really nice.
We'll talk about it. Your first test is actually going to be Tuesday. So we're going to finish up your material today. We've been reviewing a lot. So if you were paying attention and writing down information, then you should hopefully be ready. Make sure you have your pen out and a cover sheet. And a cover sheet, Danielle. Okay. Once you get your quiz, you can go ahead and start. Alright, so in that first section, write the correct answer in the blank. So you just read these questions and then answer it with a multiple choice. Write the letter of the correct choice in the blank. And then the last one is more of a thinking section with completion. You have to think through your information to decide which one would be the best possible answer. Remember, today's the 20th. That's you're asking for. You're already named. What? 21st. No, today's 20th. 21st.
No, it's the 21st.
Oops, okay. Try to write your date, then I'll fix it on the board. I must have forgot to change it. Okay.
My pen exploded when I was coming to class, and then I had to go throw it away and wash my hands.
Okay.
That was a bummer.
I'll loan you another pen for now. Be sure to get a proper pen for later. Everyone take your eyeballs really quick and look at number 10. So in science, a way of explaining an object or event using a set of facts is a or an what? Now this means that once you've taken your idea and you've tested it, and other people are starting to accept it. That's what it's describing. They're just putting it a little bit differently. So what do you call it whenever your original idea that you were testing it's proven right, and other scientists start to, and your scientists also think, okay, this one might be right as well, but it hasn't been around a long time yet. So I just hope you figure out which one it's asking for. Okay. Moving on. Oh. Oh, are you just thinking? Oh, I thought your hand was raised. What are the conditions in an experiment that are the same for all groups? So it's asking you for the variables. If you're looking at that one, what do you call the variables or the conditions that are all the same? And then for this one, in an experiment, what is the group on which the test is being performed? So it's the difference between 2 and 6. Just make sure you're reading it carefully. Don't read so fast where you're not sure what it's asking. Do your best. Based on my own point. Remember, we take it and then we take it in pen, and if it wasn't Corona, we would grade in pencil. So just make sure. Is anyone still working? Let's see, everyone's pretty much okay. Give you another minute. Still have time. We gotta talk about models. We're almost up.
We read it already.
We didn't talk about it. Yeah, talk about it. But yes, once we talk about it, if we have time, I don't think so. But yes, we'll play review games on Monday. Get you ready. Alright, anyone still working? Looks like everyone's done. You're still working good?
Someone was gonna say.
Alright, think, hurry. Okay, you gotta go eventually.
Oh yeah. I hate the way that it tries to like describe everything.
Alright, so you're done now? Alright, make sure your name and date is at the top, then go ahead and hold it, and go ahead and give it to me when I come by. I don't need your cover sheet because you shouldn't have written anything on it. This is not math. Now if you're using it, this is like a display, that's okay. But it shouldn't have been helping you with it. Alright, once you do that, go ahead and take out your textbooks, turn over to page number 31. That's where we left off, reading about your mouth. Now, we read through, well, you read through this as part of your homework, but let's go through and let's read it together as a class and then talk about it as well. Alright, who wants to read first? this is a long one, so you'll know that everyone's gonna have a chance to read. Alright, Hayden, go ahead and start.
Practically all scientific study requires using a model. When you think of a model, you probably think of a physical model, a scale model of an airplane or a train. But in a more general sense, used in science, a model is anything that provides a partial representation of something else. Models in this general sense are used all the time, not just in science. A scale model of an airplane represents a real airplane and shares many characteristics with it.
Alright, well, you stop there. I know it's on the end of the sentence, but let's give you a break because you read a lot so far. Alright, who wants to continue and finish the thought? Glenn! But it's the top of the middle column, so, but even the most detailed.
But even this is the model airplane is only a partial representation because it can never be exactly like the real airplane. The same is true for a physical model of a cell, which represents the other structures within the cell, but cannot include all the details or operation of the real cell.
Alright, so just be a note, model doing the provide the partial representation of something else. Now, who wants to start reading the next one? Jared.
There are many.
Yep.
There are many different types of models. A physical model, of course, may be used to show the structure or appearance of an object, often on a smaller or larger scale than the original. Physical models can also be used to test designs or ideas. An engineer may use a physical model of a boat to test a new hull shape, and the scientist may use a physical model of a bird wing to study the effect of the wing shape on the flight. Perhaps the most common type of model is a verbal model.
Alright, let's stop for you right there. Let's talk about the physical model. Alright, this is an example of a physical model. Now what is this representing? Alright, Hayden.
Earth.
Alright, now is this really what the Earth looks like? Is this like a 100% accurate representation of the Earth? Why?
Because it's not real. I mean, it is real, but it's not. I mean, it's plastic.
Alright, so is the Earth plastic for real?
No.
No. Alright, Evie?
Size.
Yeah, the size. This is obviously much smaller than the real world. Now, why can't we just use the real world for everything? Scott? Because it's too big. So that's one of the reasons as to how come we use models of objects that are really large. If you wanted to see what the shape of China was, and if you were to actually go over to go see China, to go see its shape, it would take you a very long time. By the time you walked around the edge of China or got in an airplane and flew over, it takes forever. So we use models to help us be able to show it a lot easier and a lot faster. In some cases, you can have a different type of model. This is a model of the human eye. I'm going to move it over here so that Josh can see it. This is what your eyeball looks like on the inside. Now, this is not someone's actual eyeball, but it's the idea this is a model or a representation of it. The muscle falls off, so I'm going to have to take it and put it off to the side. I can actually take it apart, and we can actually use it to show the different parts of your eyeball so you can see. Jack. Okay. Sorry, eyeball.
Why is my eyeball black?
Yes.
Why does my eyeball look like a 8 ball?
Because your eye, you're talking about your eye specifically, or you're talking about the pupil on the inside, or are you talking about this one?
That one.
This one, they're showing you just the shape of it. Most of your eyeball is on the inside of your skull, so your eyeball is farther back in your skull, which is good, so that way your eye stays protected. But this is part of the reason as to how come we use models, so that way you can see what the different parts of your eyeball are on the inside for it. There's more. You have your lens is not hard like that's broken. Your lens is not hard like this in real life. That's one reason why you can look down at a book and read and then look at the tree way off in the distance. It's because your lens in your eyeball adjusts basically your zoom of your eyes. That way, so you can focus on something really small, really close, and then look up and focus on something far away. And you don't even really have to think about it. Your eye does it super fast over and over and over again. So that's what the lens on the inside of your eyeball is doing. So again, this is just a model. This is a physical model. Alright, the next one is a verbal model. Alright, who wants to read that one?
You did a good job, James. Look for somebody else's turn.
Mama.
You
may.
may.
Verbal model. It's it's in the right column towards the bottom, it's in italics.
A verbal model, alright, in your scope and description.
Yep.
When you describe an event or person, you are using a verbal model. A scientist may use a verbal model to describe an organism, a process, or a scientific investigation. A photograph or illustration is a common model of the person, place, event, or theme picture. Videos and audio recordings can be used in much the same way. Mathematical models such as equations and formulas are used as models in science and in other fields.
Alright, well, up there because that was a lot of model. Alright, so a verbal model. You get this one more in practice with Mrs. Henderson in English class. The reason why she makes you use words to describe something. So if you had to describe your, we'll say your mom, how would you describe her, Glenn? Like physically. Alright, what's your hair color? Okay, blonde. You would say my mom has blonde hair or maybe yellow hair. Alright, how would you describe your mom, Lana? Tall or short? I won't tell her.
Kind of short.
Okay, that's fine. So again, what's something else you would use? Or if you had to describe your dog. You have a dog?
Yeah, like
Okay.
my dad's house. Belgian Malinois with, I'm describing the puppy.
Okay.
Belgian Malinois with a very slim, dark tail, tiny face, and more of black than brown.
Okay, so again, you're using words to help describe. That's the reason why Mrs. Henderson makes you practice and use your words more. Alright, you want to do another one? Okay, really quick.
She's old, she's white, don't have any baby.
Say it one more time.
She's old, she's white, she don't have that small.
I'm assuming you're describing a dog.
Yes.
Okay, so. Alright, what's your name? Aww. But yeah, so what's the idea of using your words or a verbal model is you're using basically verbs or descriptions. Technically verbs are more of action, but the idea you're using communication to help describe it. Alright, a photograph or an illustration, you take pictures of your cell phone or you've seen a lot of photographs. It's the idea of okay, here's a picture of an object so that way you can see what it looks like. Alright, a mathematical model, these are equations. Does anyone know what this equation is used to find?
What does it say?
S equals D over T. Scott? Speed. Yep, so it's the speed. So if you're going 85 miles, I'm gonna write fast, in 1 hour, you're speeding first of all. But then also, that's the idea of you use this equation to find it, to figure out how fast someone's going. This is the idea of a mathematical model. You're using math to figure out something. Alright, and then, let's see, we left off with computer simulations. Alright, who wants to read starting from there? You've already had a turn, put your hand down, I appreciate it, but you already had a turn. You already had a turn, Jaden. Alright, Evie.
Wait, where?
Computer simulations is in the left column on page 32.
Computer simulation programs that use mathematical models to represent objects are common in many fields. They can be used to give a vertical tour of a planned building, to predict how new laws will affect the economy, to forecast the weather, to train pilots how to fly, and to test the design of new mechanics. Biologists can use computer simulations to evaluate the effects of change in environments, to analyze how sap flows in a plant, and to calculate the strength of muscles. Sometimes an entire organism can be a model. For example, mice can be used as a model for how the human body will respond to various substances, medical treatments, and diet.
That was one reason as to how, even though it is kind of sad, they have to test new medicines on animals. Sorry, animal. But it's so that way that they want to make sure that this medicine isn't going to make a person sick. So they're testing it typically on mice first to make sure, okay, if I give this medicine to a mouse, will it get better or will it die? Sorry, mouse. And so that's part of it. That's part of the reason why they do it. Now it's one of those, that's kind of sad. Well, they don't want to kill people. And because people have more value in God's eyes than animals, we don't want to kill people by accident. So they take care of the mice though up until they die, and they don't want them to die, and that's the point. Alright, so let's go through this last section really quick, most out of time. Alright, Danielle, your turn. Read quick.
A scientific hypothesis is a model usually verbal and mathematical model tested by experiment. During experiment in the previous section, the hypothesis was that animals will grow out of different things in
entire paragraph. So yes, a scientific hypothesis is typically a model that can be used to test your experiment. Alright, 2 more paragraphs to go. Alright, Glenn already read. I think. Yeah, you read partly already. Alright, it's Scott's turn.
Testing the hypothesis by an experiment also requires using models. In the uranium experiment, you cannot possibly perform an experiment with all of the uraniums in the world. So the uraniums you use were a model representing all uranium. Likewise, you cannot possibly test all combinations of product shape and size, so the particular pots you choose used from all those pots you did not.
Yeah, that's the reason why you want to use 3 of something. You can't test all of it in the entire world. So you only want to do just 3 of it. Alright, last paragraph now, and everybody has read. Nope, wait. Alright, finish reading it for me.
Because a model is not actually the thing it represents, it can never provide a complete picture of that thing. Despite this, models are useful because they allow us to express the complexity of God's creation in a way that we can understand and reason about. Using models, scientists can make predictions, develop explanations, and communicate their findings to others.
Good job. Alright, Jaden, now what was your question?
What's a geranium?
Remember, it's the flowers we were looking at, like in the preview, like describing the geraniums and the 2 different types of pots, clay pot versus plastic pot. That's it. It's a type of flower. Your mom probably has it in her yard. You should ask your mom. Alright, your homework for tonight is you're going to, alright, these should be pretty straightforward. So, you should answer on page 33. You're going to do the explain 1 through 8. So, on page 33, there's the explain section 1 through 8. You should know all of these 8 questions already because Lisa's review to help you start thinking about it. Like for number 1, it asks you what's the purpose of science. So, what's the purpose of science? Remember, there's 3 of them.
To study how God made things.
Okay, so study the laws of nature. Okay, alright.
To study how, well, no, that would be college. To praise God for something like that, for what He made, or do that, this, that, and that.
Okay, that's part of it.
To study how it works together.
Okay, so observing nature, discovering the laws of creation, and the last one is for man's benefit, and then also to glorify God. You should already know that. Alright, you're sure to be studying those because your test is Tuesday.
You said we had a lot of homework today. It's not much.
Jaden, don't push it.
We're good.
Jaden, don't push it. Everybody, already out of the room. So be in front of me.